this example is slightly harder. We have three equations, which was the case in the last video, but in this case these are all non-linear. So we have x squared plus z is equal to 5, we have y squared plus z is equal to 17, and we have x plus y cubed is equal to 66. All three of these equations are non-linear because none of these equations have their power as 1. The highest power is not 1. So the highest power in this equation is 2, in this one is 2, in this one is 3. So how do we solve this? Remember, I told you all that in a non-linear simultaneous equation we always have to use the substitution method, and these are three equations, so we need to combine them into two equations. Now again, there's no common variable between all three of these equations. So in this equation, in equation 1 and 2, I can only eliminate z. In equation 2 and 3, I won't be able to eliminate anything. Y squared and y cubed, they can't cancel out. So therefore this is a bit of a technical example. So even though this example looks a bit difficult, we can still solve it by using the substitution method. So the easiest one seems to be either equation 1 and equation 2, where I can make z the subject. So let me use equation 1. So equation 1 says x squared plus z is equal to 5. Now I can make z the subject. Z is equal to 5 minus x squared. So I have already used equation 1 in this question. So whenever you use an equation, just like tick it so that you know you're not going to use it again. So I've used equation 1. So now what's left is equation 2 and equation 3. Now I need to solve them in such a way that I can get my answers. So I have y squared plus z is equal to 17 and x plus y cubed is equal to 66. So I'm going to be working with these two equations now. So because I know the value of z, I can substitute it directly into this. So I have y squared plus 5 minus x squared is equal to 17. So I know my value of z is 5 minus x squared. So all I've done is that I've just substituted. So my z is 5 minus x squared here. So I've just substituted it here. So y squared plus 5 minus x squared is equal to 17. So that's my first bit done. Now let me write the third equation, which is x plus y cubed is equal to 66. So I'll be using these two equations and I need to get an answer out of them. So I have y squared minus x squared is equal to 12, and I have x plus y cubed is equal to 66. So these are my new equations. So I'm solving these two. So I need to get a value of x and y from these equations, and then I'll be able to get my value of z. Notice that these equations, their highest power is not 1. For this equation the highest power is 2, for this equation the highest power is 3. Therefore none of these equations are linear. They are all non-linear equations. And so because they are non-linear equations, I need to rely on substitution. So let's see, what can we substitute? We can get the value of x in this case by just substituting. So if I have x plus y cubed is equal to 66, my x would be equal to 66 minus y cubed. Suppose if all the variables, suppose if this was x power 5, suppose, then I'll still have to make one variable the subject. So I'll have to make, say, x power 5 the subject, and from there on I'll have to solve. But it gets a bit technical because you'll need to take a lot of square roots and you'll need to do a lot of factorizations. So anyways, back to the question. We have x is equal to 66 minus y cubed, and we have x in this equation 1 also. So I'm going to be substituting. So I have y squared minus 66 minus y cubed squared is equal to 12. So it looks a bit messy, but we need to start clearing things up. So we need to start expanding this. So let's do this. So we have y squared minus, let me use square brackets so I can expand this whole thing first, and then after that I'll multiply with the minus. So I have 66 squared plus 2 into 66 into minus y cubed plus minus y cubed square. So again, this is very similar to the a plus b squared identity. I have a squared plus 2 into a into plus b. Remember that this sign will always be there. So suppose if it was minus b squared, this will be minus. That's why I've taken the minus here. So I have a squared, 66 squared, plus 2 into a, which is 66, and b is minus y cubed plus b squared. So again, this is the same as plus positive b squared. So therefore I need to take the sign. So it's going to be plus minus y cubed squared. After I get this, then I'll be able to multiply with the minus, so then I can get things on one side of the equation. So this is equal to 12. We have y squared minus 66 squared. So 66 times 66 gives us 4356. You can use a calculator for this. Minus, because of this sign, 2 times 66 gives you 132. So minus 132 y cubed, and this is minus, but it's squared, so it's going to be plus. So it's going to be plus y. 3 times 2 is 6. Remember that if you have a power multiplied or a power raised to another power, you multiply the powers out. So you have 3 times 2, and this is minus, so minus times minus gives you plus, and plus is already outside, so it's just going to stay plus the whole time. So I have this thing is equal to 12. Looks messy, but let's continue. So I have y squared minus 4356 plus 132y cubed minus y to the power 6 is equal to 12. Now I'm multiplying this square bracket with the minus sign, so I can get another equation of this form. Now in this equation we have the highest power as power 6, and solving an equation of power 6 requires a lot of time, so we'll just stick to the calculator for this type of equation. So let's get things on one side. So I'm moving the y to the power 6 and each y term on the other side, so that I don't want the highest power term to have a negative coefficient. Y power 6 minus 132y cubed minus y squared plus 4368. Because I have my 12 here and I'm just moving the 4356 to the other side, so it becomes plus 4368 is equal to 0. So I've got this big equation, and I'll have to solve this. So we had this equation, y power 6 minus 132y cubed minus y squared plus 4368 is equal to 0. Now because the highest power in this equation is power 6, we expect to have 6 solutions. I've written the solutions here from a calculator, but you should notice that the first 4 solutions have this term I. We will explore this later, but basically this means it's an imaginary number. I stands for imaginary in math. So just to preempt what I could actually mean, if I were to ask you what is the square root of minus 4, you cannot get this answer, because if you square a number, you can never get a minus answer. So, but the answer in this case, there's actually an answer to this that gives you 2i, plus minus 2i. And this 2i basically means that this is an imaginary number. So you've got an imaginary number which is not a real solution. A real solution gives you a numerical value, even if it's a decimal or a fraction, but it still gives you a numerical value. But these are not numerical values, so we cannot use any of these solutions. So these 4 are out because there's an I. Then the next two, 4.08 and 4, these ones seem to be fine because there's no I involved. So we can only use these solutions. So by use of calculator, I get my values of y as 4.08 and 4. I'm not using these 4 solutions because they have I, and I is imaginary, so we cannot use that to solve this equation. We always need real solutions. A real solution can be any type of number as long as it doesn't have any form of I. So we've got two values of y as 4.08 and y as 4, and now we need to find x. So initially we had this this equation, x is equal to 66 minus y cubed. This bit is all just to get, in fact this bit is all just to get my y, this long equation y6. So I have x is equal to 66 minus y cubed. Always make sure you reference back to the equations, because you've already made one variable the subject so that you can obtain another variable as the subject to the equation. So we already had x is equal to 66 minus y cubed, so it becomes very easy for us to get the values of x. When y is equal to 4.08, we'll have x as 66 minus 4.08 cubed, because I'm just substituting the value of y into this, and I'll also have x as 66 minus 4 cubed, because again I'm just substituting my y. X in this case will be minus 1.92. I've used my calculator for this, so you don't need to worry about solving this mentally. And for this one, 66 minus 4 cubed, I'm getting my x as 2. So I have this solution which corresponds with this, and I also have this solution which corresponds with this. So we have x as minus 1.92, y is equal to 4.08. That's one set, or we have x as 2 and y as 4. So we've got these two sets. Make sure that they are all corresponding to each other. So if I have y as 4.08 and I get x as minus 1.92, my answer cannot be when y is 4, x is minus 1.92. You cannot have it in that type of scenario. You always have to have corresponding variables. So because I have my x and y, it will become very easy for me to find z. So this was our question initially. We have x squared plus z is equal to 5, y squared plus z is 17, and x plus y cubed is 66. Which one seems to be the easiest? To me, okay, we'll have to use z in one of the equations, so we only have equation 1 and 2 to choose from, because equation 3 already makes sense because we have x and y for both sides, so we can't use equation 3. So the easiest equation to use from these two would be equation 2. So let's get the value of z. So equation 2 says y squared plus z is equal to 17, and from there we can find the value of z. So because we already know the value of y, we can just substitute it to get the value of z. There's no x here, so just forget about the x for this moment. So when y is equal to 4.08, I have 4.08 squared plus z is equal to 17. When y is equal to 4, I have 4 squared plus z is equal to 7. So by use of calculator, I know that my value of z in this equation is going to be 0.35, because I do 4.08 squared and I do 17 minus the answer of this. So I get z is 0.35, and this one I get z as 1. So I've got my values of z. Therefore the solutions to this equation are x is equal to minus 1.92, y is equal to 4.08, z is equal to 0.35, or make sure you have this all written and make sure that these solutions are all corresponding. So when I have this and this, my answer is this. So these should all be corresponding. So or x as 2, y as 4, and z as 1. So I've got two solutions to this equation. Although the maximum number of solutions I could get is actually 6, because I have the highest power as 6 in one of the resulting equations, but we can't use these 4 because they're all imaginary solutions. So that solves the question. X, y, z for both instances are all done.